Hello, everybody. My name is Robert Hodges, and I'm CEO of Altinity. It's my pleasure today to introduce two of our friends from eBay, Sudeep Kumar and Mohan Garadi, who will be presenting on migrating from Druid to next-gen OLAP on ClickHouse. Before we get into the webinar, I would just like to draw your attention to a few things that may help you have a better experience in attending. First of all, this webinar will be recorded, and it is being recorded now. The slides as well as the recording will be posted as links after the talk. Second thing, we anticipate that we'll have plenty of time for questions. If you have questions as the talk is proceeding, go ahead and post them into the question and answer box. It should be available to you off the menu bar at the bottom of the screen. So just feel free to post them in. We may answer some as we go along, but there will be time at the end, and hopefully we'll be able to get to every question. Finally, we run a short poll at the end of all of our webinars just to find out whether the content was at the right level, as well as understand future topics that might be of interest. So you'll see that it takes you all of 10 seconds to fill out and helps us make future webinars better. With that, it's once again my pleasure to turn this over to Sudeep Kumar and Mohan Garadi. So gentlemen, take it away.
Hello everyone. Just to make sure, is my audio clear, Robert?
It's perfect.
Hi. So I'm Sudeep. I'm a senior engineer within eBay, and we also have Mohan today, who will be co-presenting the webinar. We are part of monitoring and telemetry team within eBay. So today, what we intend to do is to talk about our story of how we migrated our OLAP backend from Druid onto ClickHouse using Kubernetes. So talking about eBay, right? It's important that I introduce eBay first. So eBay is a global e-commerce leader with operating within 33 countries. We have around 180 million active buyers. We had around 27.1 billion GMV in Q2 2020, and we have around 400 million plus downloads of eBay app around the world. If you look across different 5 continents, we are there in top 5 in 3 of the continents. So whatever we are presenting today, just to put it out there, we are also published as a tech blog, which has come out yesterday. So all the content that we have here is available in our tech blog at ebaytech.com. Okay, talking about our platform. Our platform is called as Sherlock.io, and it is a platform for all the monitoring needs within eBay. So we monitor anything and everything, such as application, networks, and devices. The platform is centralized in nature and handles all kinds of monitoring signals. It could be logs, it could be metrics, traces, and events. To give an idea about the scale of our platform, we handle around 8 million metrics per second, and we have around 1 billion raw events per minute. We handle low single petabytes of daily log volumes every day, which is fairly large. So it's a good time to introduce Sherlock.io events. So I think most of the developers are familiar with logs and metrics. So logs generally are anything that the application creates. It's quite verbose in nature. Metrics is time series data, right? So what we did is that we defined something new. Like we have called something as Sherlock.io events, which is somewhere between a metric and a log. So it is the nature of an event is such that it is as verbose as a log, but you can do aggregations at scale, just like what you would do for metrics. So it's somewhere in between. They are immutable, and they represent some key signals in the system. That could mean one of your databases have failed, or one of your devices have failed. And the volumes of these events are often sporadic, right? Because when something happened in your system, generally you tend to see a lot of these events coming in. So you should be able to handle that kind of volume and surges. They adhere to a predefined schema format, and they are typically not limited by cardinality of data, which if you look at today, most of the metrics backend systems are typically sensitive to. So if you have like you can run out of memory in some of these more recent databases, wherein you have to keep these series in memory to take advantage of few of the things like delta encoding and things around that. So it's not really limited by cardinality of data, and this is what we wanted to define as a nature of an event as well. To look at a few of the examples of event use cases, we can look at application traces, your OLAP data, and generic events. Wherein when we say generic events, it could be something when customer comes to you and says, okay, this is my event and this is how the schema looks like, and this is a daily volume I would like to ingest into your platform, and that becomes like a generic events use case for us. So as we go along, I would encourage folks to actually put in your questions, and if I can get to it, I'll get to it as we are speaking. Else towards the end, I can take all these questions as well. Now it's important to understand why we had to look at alternatives, right? So we had a system that we had created using Druid, and it really worked for us over 3 years, and it was quite stable. But as we moved along, we saw increase of volume, and there was increase in capex requirements and so on. At some point in time, we had to justify this capex needs that we had to use for Druid packet. And there were just too many moving parts for DevOps to maintain. If you look at Druid, there were like a lot of components which work fairly well, but you need to be really aware of all these moving parts, which our DevOps may not be comfortable with. As we not just handle Druid, we actually also use a lot of open source technologies like Elastic, Hadoop, and so forth. So it's just hard to keep track of so many things. More recently, what we have done is that all our workloads have been moving towards Kubernetes. And as we try to move our deployment towards Kubernetes, we did face some availability challenges. Now, this is specific to eBay, right? Because eBay, within eBay, we have our own platform called test.io, which essentially is like a Kubernetes as a service. And it has its own challenges with respect to network availability and so forth. So we saw some challenges there to run these workloads. And we also thought, if we can prove this backend for OLAP with ClickHouse, we probably can look at the same backend for future generic events use cases. And it could be a good fit, because we have requirements wherein we need to be able to handle generic events, wherein customer comes and says that this is a schema that I want you to handle. So these are the reasons that we were actually looked at why we had to go for something else. With this, I'll actually hand over to Mohan, who will talk about what pipeline that we had before, and then we'll introduce how we moved on to ClickHouse. Mohan?
Hey, thanks, Sudeep. So like Sudeep gave a key introduction, so I hope everyone is audible. So like Sudeep said, we had our own challenges, right? So to begin with, our initial volume on Druid pipeline was around 250 million events per minute. But as shown in the previous slide, over a period of 4 years, the traffic volume has grown around 400%. So just to give an idea of what this pipeline would look like, so there are around like 6,000 applications at eBay, give or take. It's a little more probably today, but at the time of writing this blog, there was around 6,000 applications. We call it like application pool. So a pool represents a set of machines. So each app could have different set of machines. So this number would be somewhere around 200K machines, right, overall. So all these machines send events in a specific format. So there were around 11 dimensions and 2 metrics in this use case. It's a fixed schema, but values could be anything. So we are looking at around a cardinality of around 20 million unique cardinals coming in. Volume is around today a little more than 1 billion per minute. These applications push the data into Ingress. This is our own Ingress that's managed on our Sherlock.io backend. Then this Ingress actually kind of does a high level aggregation, right? Like not the overall aggregation level like the analytical engines do, but just to reduce the amount of volume coming into the system. So the data comes into Kafka. It is just a messaging system that we have in place in case should something go wrong, we should be able to go back and replay from the time we could have potentially lost the data or things like that. But eventually, this started to cause a bottleneck as well, because going back in time for this kind of volume in case of there is a data loss is very challenging. So that way we have to make sure, like, hey, we don't lose the old data for the period we missed, and also the new data that's coming in. So you have to make a right choice. Either say like, hey, we are going to say like, hey, it's okay to lose old data because we don't care in case there is data loss, but what matters for monitoring is real time. Everything else below Kafka that you see is Kubernetes deployment. So given that there are no guarantees made on how the deployments happen on Kubernetes, in terms of, let's say a pod goes like dead for some reason, and then you just need to see how you want to bring it back, and can you actually get back into the same state you were earlier in terms of data. So that's a big challenge. Another thing is like in the next slide I'll be showing like what kind of scale we are operating in Druid here. So this is just the architecture of that one. So then everything else coming out is egress, which we get the data out of Druid using the Druid brokers. Also on top of that, we have our own egress layer that's going to get the data out in a certain format, because we should have control over what kind of backend store we use. So there is a separate layer on top of Druid brokers to egress the data. So that way we can control what format we want to enforce to the user to query the data. So there are other tasks that run outside of Druid workload, which itself is a batch reindexer that you see on the left side. So the batch reindexer, what it does is it's basically for the higher temporal aggregations. So let's say you want to do daily aggregation. So that we don't want to do it in real time because of the resource cost for the hardware that incurs to do the real time. So we had to do the batch. So one day is not a real-time requirement. So it's just a thing for people to use it for triaging over a long period of time. Moving on to the next slide. So Druid infrastructure footprint looks like this. So there are like these 6 components we are talking about. The top 5 are basically only the Druid standalone components to run the Druid backend. Tranquility is just an ingest API. But it still costs like pretty huge capacity. So this is all the capacity show up for one region. So to operate Druid at scale, we need to have 2 such regions, because we cannot operate Druid on a single zookeeper that spans across regions. The reason is that if something goes wrong with partitions going down, because let's say a pod running a partition went down. So in that case, if the partition is run, if the 2 replicas of the same partition is running in 2 different regions, that would cause a problem. So we had Druid deployment, like 2 standalone deployments running in 2 regions. And for each region, we have 2 replicas per partition. So why we incurred this kind of a huge hardware hit was basically a couple of things, right? Like one is we need to have different granularities that we need to support. Like let's say this is mostly for SRE and application developers to triage if there is an issue. So you need data at 1 minute granularity. But as you grow towards like number of days of query that you want to do, 1 minute granularity doesn't hold good anymore. So you just need to move to 15 minutes next. Let's say you're doing like 5 or 6 days. 1 minute will get like really, really slow when you go to historical data. So you just need like a 15-minute granularity, but going to like 15 days or 3 weeks or something like that, 15-minute would start to slow down and you need like 1 hour granularity. So we were doing real-time ingest for all 3 granularities. So that way all 3 are available for triaging and in terms of availability when people are querying for a long time. Mostly the highest in terms of capacity, the consumers were middle managers and historical nodes. And this is per region. So with this in consideration, the daily re-indexing I was talking about earlier in the previous slide. We had to do re-indexing because if you were to do another real-time ingest for 1-day granularity, it again incurs at least 25% more hardware than what we are presenting here. So that would be a huge challenge in terms of hardware. Moving on to next slide. So there were other challenges, right? Like for example, there will be special days like seasonal traffic or some application is doing a bad logging. Of course, we have protection in place for system to not take any bad logging, but it is a feedback loop. So we will still have to let the traffic into Druid for some time to calculate that there is a huge surge in some kind of cardinality. Let's say somebody decided, hey, we're going to put item IDs or seller IDs on my application's events, and that suddenly increases the cardinality. So for that to be calculated, we have to go to Druid, calculate it for a certain period of time. We see like, hey, this application is exceeding some threshold that we have, then it has to be a feedback loop. So that kind of bad logging, if that happens on multiple applications, that would definitely take a hit on Druid real-time processing. So resources always had to be kept over-allocated so that we don't take problems like these affecting everybody else, right? Second thing is too many moving parts. So it has like 5 different components that we need to run for operating Druid. And if any of these go wrong, however, Druid is advertised to be like none of these actually causes a single point of failure. But in reality, while operating, if more than one of these things go wrong in different collocations, that would still pose a problem. So we have seen that in our experience in the past. Additional deep store also needs to be configured for higher availability, right? So for high availability, if let's say you want to bring down historical nodes for some reason, let's say Kubernetes platform is not available for some time and they just got the nodes down that was running historical, and the disk was also taken out. So you don't have any context of historical data now. So all you have, because there is no cross-regional talk between 2 different Druid clusters, so you need to configure a HA deep store for data to be retrieved in case something goes wrong with historicals. And higher granular temporal aggregations needs re-indexing. Like I explained earlier, we at least needed like 25% more hardware if we were to do real time for 1 day, basically 1 day granular indexing. So that is one challenge. Kafka indexing options were very slow. So there is direct Kafka indexing plugin. So what we were showing in the previous slide, previous to previous slide was Kafka Druid taking data directly from Kafka. In reality, there is one component that is actually missing in that diagram. The reason is basically there was a direct real-time ingest that was happening. So that means we tried Kafka indexing, direct Kafka indexing from Druid. So for this kind of volume where there was around 250K events per second, it used to get very, very slow. So direct Kafka indexing actually has to do periodical commits as Druid reads data. So Druid processing, if it slows down for any reason, the Kafka commits slow down and the lag will build up. So the lag was really, really bad. And over a period of time, what would happen is it was not able to catch up. So that caused a huge problem. So we said like real-time ingest is the only one that works for us. So that means we read from Kafka. So we will have the Tranquility API in between. So we then send it to Druid as if it's a real-time data. However, the data itself is near real-time. It's not real-time. The data could be delayed from each application for up to 3 minutes, right? With that in mind, we had to do real-time ingest. So these were some of the challenges we faced. It worked pretty well for the first couple of years. In the last year of when the traffic was almost like 400% more, we kind of started to face these issues related to direct Kafka indexing and things like this. Yes, next. Yeah, thanks. So I think from here, Sudeep will take over. Yeah,
Yeah,
thanks.
thanks, Mohan. So yeah, as Mohan explained, there were multiple things that we had to take care of to run Druid for OLAP use cases. So and at some point in time last year, we looked at what are the different alternatives, right? We looked, because since we were comfortable with Hadoop, Elastic, we did explore them, but things were not working out as we wanted them to. And towards the end of 2019 is when we stumbled upon ClickHouse. And initially we just started looking at ClickHouse as a POC, and almost immediately what we realized is that it has very impressive ingestion numbers. Like if you and especially as your batch sizes grow, it can really eat up any kind of volume. We also did some comparison with respect to storage, because most of our questions on the legacy platform was why you have to spend so much resources for storage. So as we looked at this, what we immediately realized is, if you compare something with Elastic, which stores inverted index, the storage requirements are much higher. And while it works very well to search sparse data on Elastic, but of course the storing inverted index onto disk has its own storage capacity challenge. So when we compared that, we saw that okay, we have like 500% storage savings if you just do it on ClickHouse, say, versus something like Elastic. And we had these POCs done. We just, and this is just a POC code, right? And we incubated this setup over multiple weeks. And surprisingly, what we saw is that we didn't really encounter much issues as we kept this running, which really meant that the system was quite stable. And we decided at that point in time to look at this very closely and invest time here. Another thing that we realized is that there is already a ClickHouse operator which Robert and team has created, which worked very well for us because we already were running workloads on Kubernetes. So we thought, okay, maybe we can just leverage this, the open source ClickHouse operator directly onto our Kubernetes platform, and then things should be much more seamless. And OLAP story, of course, did fit nicely with our ClickHouse backend, which was always an advantage. Now talking about ClickHouse and Kubernetes, right? There were a few things that we decided to do. One is to leverage the open source ClickHouse operator to spawn these ClickHouse clusters locally. At the same time, what we wanted is for our ingestion and query layers to be aware of the ClickHouse infrastructure directly, so that we can work out of IPs. The reason why we wanted to work out of IPs is because, again, if you look at eBase network, and typically some other huge networks, internet networks, you have issues with respect to DNS propagation delays and DNS consistencies. So we just didn't want to work with DNS name resolution, but work out of IPs directly. So as part of that, what we did is that we created a thin ClickHouse discovery module, which basically just looks at the annotations of different pods. And in the annotation of the pod, you would basically have saying that this is a replica ID and this is a shard ID, and based on which you can create a logical cluster topology. And this particular library would continue to observe all the life cycle of the pods, and you can say that whether the pod is ready or not ready. And this data is being made real-time available onto our ingestion and query layer. So they really have a good, healthy snapshot of the cluster. So we took advantage of that. And as I explained earlier, the open source operator aligned well with our existing deployment strategy, so we did leverage it. So one limitation that we saw was, and that is something very specific, right? What we do is we run typically workloads, or all our distributed applications are hosted across multiple regions. So you will have a region 1 and region 2, and you will have application hosted on both. The reason is resiliency. While the operator worked well to create the local clusters within Kubernetes, it didn't really take care of the cross-region ClickHouse cluster that we really wanted. So as part of that, what we did, okay, we decided this is something that we need to come in and put in some engineering effort. So we created our own custom operator basically that handles two custom resources referred to as Federated ClickHouse installation and a Federated ClickHouse cluster. So we have controllers which run, look at all the instances of the custom resources and take actions based on it. Looking at the FCHI or the ClickHouse installation represents the different clusters that are deployed on our Kubernetes infrastructure. The way we have designed it is that you can have multiple ClickHouse clusters on our infrastructure, and that is one of the advantage what Kubernetes provides. That you can easily spawn as many clusters as you want, and we wanted to really take advantage of that instead of having a monolithic single huge ClickHouse cluster where you have all the data coming in. So that's something that we decided to do. And the other object was the FCHC object, which basically would create metadata for the ClickHouse cluster on individual Kubernetes cluster in different regions. So it will have the metadata saying that, okay, for cluster 1 in this region, these are the settings, and in this region, these are the settings. Basically, it will use the open source ClickHouse operators objects to spawn them within these local clusters. So that's the model that we worked with. We did have multiple iterations to really harden this and get it into a very stable working state. On top of this, we also have a lot of monitoring created so that we know what exactly is happening in case of any state inconsistencies. But this really has turned out well for us. Just to give a little bit of snapshot of what these objects represent. So we have the ClickHouse installation object, which basically, as I said, like represents different kind of clusters that we have in infrastructure. And for every ClickHouse cluster, say Sherlock events that was there as part of OLAP, we have the different settings that needs to be applied. So this is the metadata that we keep. Another advantage of keeping this, these controllers are running on federated control plane on Kubernetes. So and they don't run on local Kubernetes clusters, right? That's how our deployment looks like. Yeah, let's go. Let me see if I have some questions here. I can just pause here to see whether I can take some questions.
As Sudeep, you have 3 queued up if you can see the question and answer box.
Yeah, I'm trying to pull that up. For some reason, it just isn't coming up. Let's see here. Okay.
We can also cover them at the end as well.
Sure, let's do that. I think I have some difficulty getting them up. Okay, so in terms of architecture, this is what our overall high-level architecture looks like. We have ingress and egress layers. Ingress means your ingestion layer, and egress means your query layer, right? That's where all the query traffic is coming from, and ingress is where all your ingestion traffic is coming from. So, ingress layer is actually created of multiple processors, and they are like stitched like a pipeline. So, the moment you get a signal inside your ingestion layer, it goes through different pipeline stages. First, you validate the signal, then you see whether it is adhering to the schema or not. And once if it adheres to the schema, we look at we do a lookup on the backend infrastructure where it has to be written, and we go ahead and write onto the infrastructure and give an ACK back to the client. At the same time, what we additionally do is that we push some of these data onto Kafka backend as well. So as we talked earlier, the ingestion layer and the query layer uses this thin library called the ClickHouse discovery module, which essentially creates this cluster view of the ClickHouse infrastructure and can really get all the different real-time states of the pods to see whether the pod is healthy or not, and will only use those handles to write the data in. So as your availability is pretty good that way. On the query layer, we have different formats that we have exposed. We'll talk about that later, but the most popular one is through actually visualizing the data through Grafana. And this particular visualization uses our own custom data source that we have on Grafana, which is adhering to a particular API format. So we encourage users to come onto a platform and use this particular plugin to visualize the data. On the egress layer, we also have a remote read and remote write of Prometheus being implemented. That way, your Prometheus alert manager can directly plug in onto egress and create, you can potentially have an alerting layer as well. So we try to take advantage of that. The users can, of course, also have API-based access, for which these are always access controlled. So you need to basically authenticate yourself before and authorize yourself before you actually can query anything out of our backend. And the ClickHouse cluster itself, if you look at it, they are deployed across 2 regions, region A and region B. Typically what we do is we have like 2 replicas in each region. So we have like 4 copies essentially across 2 regions. And that's the model that we are going with. So I think Mohan gave a quick insight about what kind of footprint Druid had. If you compare that against ClickHouse, you will see an immediate benefit, right? If you look at, this is the total infrastructure footprint that we have on OLAP, for OLAP on ClickHouse across 2 regions. This was actually fairly impressive for us, and probably this is also a little over provisioned, to be honest. But this is what we have currently in production, which seems to work very well. So we have like in total of 688 vCPUs, a memory of 1.7 TB, and 46 pods that we run in total. See, we have some we run for Zookeeper and some we run for ClickHouse. So the OLAP data itself, when we talked about OLAP data, how is this OLAP data? How does this OLAP data look like? So we have like 14 fields within the OLAP data. Each one of them, each of these attributes are listed as in this table, as mentioned. Probably not very important, but we did few things like we take advantage of low cardinality whenever we can. Also, the way we order is also important, because what happens is generally whenever someone queries for data, it always has a pool information with it. So pool information typically represents the application information. So we always order by pool and then the timestamp and followed by other labels. So that's what we try to do. And this model really has helped us to look up much more faster. Additionally, what we have, we do is that we use buffer tables. So sometimes in some of the ingress nodes, what we have seen is that the batch sizes could come down, and that would create just too many files on the backend. So we really don't want that. So if we see that a batch size is not meeting a particular threshold, we write into the buffer table directly. We want the system to be eventually consistent, so that's fine. Like it would take its own sync time to actually persist back into the backend, which works well for us. We have different materialized views for 15-minute, 1 hour, and daily data. So you basically have these different materialized views created on this particular table. On top of it, we have retention policy configured. So retention is something like I like to talk about a little, because initially when we started with retention, we just thought like, let's use time to live and maybe we will be done with it. But really that didn't give us a lot of control, and we did run into occasionally some issues where sometimes it was not honoring the TTL. So what we instead decided to do is, okay, let's not use TTL. Instead, we will just look at the different partitions and just drop the partitions if they exceed a certain size. So that worked well. And that's a model that we are running with in terms of retaining data. So different tables have different retention periods configured. So yeah, Mohan, do you want to comment?
Yes, thanks, Sudeep. So as for the query layer, we do support like 3 different formats. So event QL, that we call it. So this is just a stripped down version of the prompt QL, right? So the reason for supporting this kind of querying capability is this naturally fits in with our existing use case for metrics, because metrics we are using Prometheus, so it's naturally prompt QL. So we thought instead of developers learning a brand new language again, since they're already comfortable with writing prompt QL like queries, event QL would exactly look similar to that. The only thing that we need to do here, at least in this version of our own prompt QL that we implemented, is for OLAP data that already has counts and other numerical columns aggregated, it's okay, because you know what column you want to do the projection on for aggregation. But for rest of them, let's say for some of the other events that that customer wants, it's just they want to read out only the raw events. So in case of raw events, there is most likely no numerical columns. Let's say all raw events are string values. So we fabricate like an extra column in ClickHouse saying like there is a numerical value with a default value of 1, let's say, for every row. That value is really not used. It is just to make it compatible with PromQL style querying. So that way we always assume there is a numerical value associated, even if it's just a dummy value in the ClickHouse table. It's just about reading the data in the PromQL format. Second is the custom event format. So we had event store on Elasticsearch, like Sudeep was mentioning earlier. This one was just to keep it backward compatible. So this is nothing fancy. It's really a JSON payload that you just send with what columns you're looking for, what aggregations you're looking for, and time range. It's as simple as that. Third is, of course, the SQL, the native support that's provided by ClickHouse. For SQL, it's really not integrated with our Grafana today as we speak, but probably we could support this in future. But this support is there if somebody wants to query it through an API, where in the API they just want to do a get call to our backend through our egress and just provide a natural SQL query, and it just works like any other SQL query. So that's the SQL. So based on what the user is looking for, so let's say I was mentioning earlier, like in Druid, we used to do like 1 minute, 15 minute, and 1 hour. Here we really don't have to do like 3 different real-time ingest into different tables. Here what we really do is ingest into a single table, like a raw data as it comes in. Aggregations does happen on materialized views on top of the concrete table. So that means for 1 minute, 15 minute, 1 hour, and 1 day granularities, the aggregations does happen in real time as data is inserted into the concrete table. So based on, let's say, user query, we optimize it in a way that, let's say, user is looking for 6 hours data, for example, or even like 1 day worth of data. And if they don't specify granularity, we can still fall back to the least granular data, which will be 1 minute, let's say. And if in other cases, if they want like 1 week's worth of data, then we know like we have a preset interval of time for which we need to fall back to the next granularity. So we probably move to 15 minutes data. Even further, like 3 weeks, probably go to 1 hour data. And anything more than a month or 2 months worth of data the user is querying, it will fall back to 1 day granularity. But all this data is available until the current minute where aggregations are happening, if data has already arrived. So we don't have to do anything else apart from setting up the materialized views. Yeah, next slide, Sudeep. Yeah, so just to give a gist of how the query layer itself is set up. So we don't have, so as per ClickHouse, we don't have the distributed tables created on every ClickHouse cluster. Like Sudeep was mentioning, we could spawn like even like, 50 clusters at some point, individual ClickHouse clusters that has its standalone installations in every region. But what we do is we have a concept of a query cluster. So these query clusters are basically a standalone ClickHouse cluster that doesn't do any kind of data ingest, but it is just a cluster that hosts all the distributed tables. So that means if we have like in the picture I'm showing, like there is one OLAP cluster, another one is just say there is a generic events cluster that customer is sending data to. We have distributed tables created for each one of these. Then the cluster mapping happens based on what cluster you specify in the distributed table. So for every OLAP query that comes in, we just hit the query cluster for OLAP, and it naturally goes into OLAP cluster pods to get the data from the concrete tables, combines the data and returns it back to the user. In case any other generic events come in, it goes to the generic cluster as shown here. So it's always mapped to the right cluster. So as we onboard any new schemas, we naturally we figure out like which cluster is least occupied. We just create tables there for concrete tables and buffer table definitions there, and all the distributed table definitions happen on the query cluster. So that way we are all set, and we should be able to query the data as soon as the data starts coming in from the query cluster. So this is all I have. So Sudeep will
Okay.
take over from the monitoring.
Thanks, Mohan. So, important part of everything that we had built is monitoring, and which I'm sure most of us are already doing, right? And these days, most popular one is via Grafana-based visualizations. Few things to touch upon that other than just doing infrastructure monitoring, we do extensive monitoring on both our ingestion and on our query layer. So this includes things like how many requests per user is being fired, what is the average duration that is being fired for the particular user. Based on this these things, we can either plan to blocklist a particular user, or we can actually say take a few more things like, okay, maybe we need to add capacity if it is really a valid use case. um, we definitely use a lot of dog fooding, because we are the monitoring platform of choice within eBay. So we use our own platform to do a lot of these capturing of these metrics and creating alerts on top of them. We do have parallel systems that we have in place just in case the availability of our platform is in question. Then we can always depend on them. But we always prefer the dogfooding operation. That's like the first place where we go to. We go onto our own platform to check whether everything is working fine, and that gives us a good insight about how really good your platform is, right? And we have always taken this approach for everything. There are a lot of alerts that we have created for with respect to availability. So if, for example, if our ingestion is having less than 99% of availability, we get an alert on the query. If we see that there are queries wherein too many rows are being scanned and they're just timing out, we have alerts based on that. So these give us good sense of availability of the platform. So generally, like, when you say availability, we just don't look at the downtime itself. We look at all these aspects as well, and that's how we measure. And that's I think that's really a good way to measure what the customers are seeing on the platform, and that's what we try to use. So other considerations, right? So one we just spoke about is on monitoring the signals and measuring availability. We also do tracing. So now for tracing, we have our own tracing setup. We use Agar for it. If we briefly touched upon our ingestion layer, wherein we have different processors. So if you look on the right, you'll see like whitelist, validate processor, sanitize, then you go ahead and validate the schema, then you have the ClickHouse. So we have all this information here. If there's something fails, we get a lot more insight about what's really happening. At some point in time, what we would look at even storing some of these back into ClickHouse if possible. But right now in current state, we are using Agar for it, and it has really helped us to debug. One thing, as we created the new platform, we wanted to make sure life for our DevOps really gets better, right? And that was something that was hugely missing in the previous pipeline that we had. So immediately what we decided is that, okay, I realized that if we don't enable DevOps to do their job well, there would be a lot of complaints and a lot of interactions which we wanted to avoid. So immediately what we did is, okay, let's create a CLI with which we can look at different ClickHouse clusters that is there on the setup, what kind of disk utilization is happening, what kind of memory footprint. So all this you can do via the CLI. You of course have to log in, provide your credentials, and then you can query these clusters and get a good snapshot. This has also helped us a lot. In terms of Zookeeper deployment, the way we work is, as you said, like we want to have everything distributed across 2 different regions. So we have Zookeeper across 2 regions. One region always acts as always participate in the leader election, while the other so I should be mentioning other region always is always in the observer mode. So one region availability is impacted, we have to go in and flip the other region to leader elect mode. We are trying to automate few of these things here on the Zookeeper. However, we are not yet there where we want to be, with respect to this particular story. But this is how we do the Zookeeper deployment on our infrastructure. To summarize, one immediate difference that we saw is very high ingestion throughput, and that's what we really wanted. We were quite happy with it. We had reduced processing layers, so we didn't want too many moving parts, and that helped with it. To be honest, we were also quite comfortable with Zookeeper. So if there is just a Zookeeper dependency, I think we were very comfortable handling it. Then we also saw reduced storage footprint, which of course definitely helped. The main important thing is it's been very easy to manage since our migration. So we hardly have had any incidents for last 6-7 months since we have migrated. So that's been a good success story for us. So less incidents for DevOps, better for us. And since availability was better, and also what we saw is that our customers, which is SRE, which Mohan mentioned previously, we're very happy with the new platform in the way they got their output back immediately in terms of the general availability of the platform. So this is where we are in terms of a story with ClickHouse on OLAP. At some point in time, we would look at whether we can support generic events use cases on ClickHouse also, and we have already started putting efforts around it. This is a typical slide with every presentation, I guess. But yeah, so eBay is of course hiring. We are hiring across all the different cities and countries. Remote work is definitely an option in the current times. In fact, we encourage it right now. There are a lot of areas where we are hiring. Some of these are listed below. You can always look at careers.ebayinc.com. Please also reach out to Amber Vaidya, who is our engineering head for monitoring team. Yeah, he will be happy to help. With that, I'd like to thank everyone who's been on the call. Thank you so much for your time and patience. I think it's a good time to pull up the Q&A.
Yeah, let's do that. Let me jump in for a second here. I want to thank you, Sudeep and Mohan, for a really awesome talk. Also, I want to thank you for all the feedback you've given on running ClickHouse on Kubernetes. We've had conversations with you over, I think it's almost 2 years at this point, sort of discussing what you're doing, and it's been great to see this develop. So I'm going to go, for those of you on the call, I'm going to go ahead and kick off our poll right now. Please do take a few seconds and fill it out. It'll help us do better webinars in future. And then Sudeep and Mohan, so I think that what might work best is, why don't I just go ahead and read the answer, the open questions out, and then you can just jump in and answer them.
Yeah, sure.
Okay, great. So first one, thanks eBay team. This is a great presentation. I'll say yes to that. Question about other alternatives you considered as Druid replacements.
Sure. So one thing we considered, like we looked at Hadoop. Hadoop, of course, it can really take a lot of these traffic and can do a lot of things that we wanted, but they were not real time, right? You have to run a map reduce job offline and see whether it essentially you need to run, which is not really real time, and that was really limiting for us. So we didn't. Although we looked at it a little bit, we didn't want to go that route because it didn't really work for us. The other one we looked at was whether Elastic works well, because it's also quite popular within eBay and we use it for a lot of different things. And some of us are very comfortable with that backend as well. So as we looked at, we just saw that the cost was not justified because, as I said, like we saw 500% improvement in storage cost on having it on ClickHouse versus on Elastic, and that's our personal observation, right? And with that, we decided, like, okay, we are running into the same issues that we had before, which we probably didn't want. So these are the two that we definitely explored, and then we just looked at ClickHouse. So I would say 3.
Great, thank you. Next question: does ClickHouse have equivalents to Clarity and Pivot for Druid?
Clarity and Pivot for Druid. I'm sorry. Mohan, do you want to take that?
We haven't explored that option, Doug.
So what if I can like double click on that? What does it mean, Robert?
I'm just saying, the person who asked that, if you want to go ahead and qualify that a little bit, we can dig more deeply into it. And meanwhile, we'll go to the next question.
Sure.
Next question is regarding clustered ClickHouse. What happens when you want to dynamically resize the cluster? Does ClickHouse manage that automatically for you, or did you implement it for yourself? How
Oh,
long
yeah.
does
Oh,
it
that's
take?
a good question. So it actually happens immediately. I mean, if you're talking about the latency, as long as you have capacity, it can be done. The way we do it is we mentioned about two resource objects on federated control plane, right? That our controllers run on. One is FCHI and FCHC. Now, FCHC is the federated ClickHouse cluster, which has a metadata about how the cluster has to be created. So it would say I would need 2 shards in this cluster and 2 shards in two shards in this region for this cluster and 2 shards for this region in this cluster. You can always increase that particular number, and then what would happen is that the controller would look at, the spec says that this is what I need, but the current state is not this. Let me use the ClickHouse installation object, which the open source ClickHouse operator uses, and spawn those additional shards. Essentially, there is not much delay as long as we have capacity. We haven't seen any issues. To be honest, we haven't done a lot of resizing on our clusters, so I cannot completely vouch for what kind of stability we are seeing with all this.
Great. The next question is what database to use, and I think that was in reference to something else, so I'm going to pass over that one. Person who asked that, Anish, if you could just qualify that, what you meant by that, we'll be happy to answer it. Next question, can ClickHouse handle batch fetch, like tens of millions of records? Are there any limitations? Not sure ClickHouse is designed for this type of usage or not.
Yeah, Robert, do you want to answer that? I think.
Yeah, I'll take that because this is a general question.
Yeah.
Usually people don't do this, and it'd be interesting to understand what your use case is. What you typically do with ClickHouse is for example, you're processing aggregates, or you're doing something like in this OLAP case, you're drilling down on a particular service or transaction type to understand why something is not working. So, and in these slicing and dicing cases, the drill downs tend to be on relatively constrained data sets. That said, there's nothing that prevents you from from doing a batch fetch out of ClickHouse using a select. The one thing I would say is, depending on what problem you're trying to solve, you might be better off pushing the data into something like S3 and using that as your exchange format. And that's only because if you're doing it at real scale, like the kind of scale that we're talking here, it's an enormous amount of data, and downloading it over a single connection is not the most efficient way to do it. So definitely definitely an interesting question, and one that if you're interested, feel free to go deeper on that one. Okay, here's a question, great question. Were you storing an equivalent amount of data in both Druid and ClickHouse? The equivalent with regard to binning was a bit confusing.
Yeah, in terms of volume, if the question was in terms of volume, yes, it was equivalent. It was the same data. Great. In fact, the way we worked is also, so the way we switched over is not like an immediate cut over, right? Like what we had is that we did run both the systems running for a period of time, both Druid and ClickHouse. And we wanted to incubate our ClickHouse setup for like a month or so. Between this period, we started seeing some more issues on Druid. At that point in time, we just said, okay, let's do the cutover even before it, and let's see what happens. So we did a cutover within like 2 weeks of our data being ready, our data pipeline being ready. So yeah, that's how I think we went about it.
Great. Next question, if MySQL is your database, and I don't know if this is relevant, did you replicate the data from MySQL to ClickHouse? Was that relevant for your use case?
No, because we weren't using MySQL in any capacity, at least.
Okay.
Within,
what I'll just throw in here is there is Mohan, do you want to jump in on that?
Yeah, so to answer Anish's question, one thing just flashed on my mind was there was a recent use case where we have a logs storage system. So basically, there is metadata associated with that itself. To store the logs, there is some metadata that we need to look up, right? Like where the logs are stored on the file system. So that metadata itself is a huge scale data, which was using a MySQL database earlier on. But again, they had issues with deduping the data and things like that into MySQL. It's our own platform monitoring use case, by the way. So we had to migrate them out of MySQL into ClickHouse. They're not fully migrated, but we did a POC. It was pretty successful, and we use the ClickHouse native capability to dedupe the data, and it's quite successful.
Yeah, and just for anybody who's specifically interested in replication from MySQL to ClickHouse, there is a new engine in ClickHouse which can actually read the bin logs. It's called, I believe, MySQL Replicated. I haven't personally used it, but it's coming up. Here's a question. You mentioned that ClickHouse is great at compressing data, and are there any numbers on your previous Druid storage capacity versus current ClickHouse?
So to be clear, right, when we said the storage cost, we were not really looking at Druid per se. Like we were looking at specifically Elastic as another potential option. And that's where we did the comparison for the cost, because that also looked very promising to us, right? And that's where we did try to see what's the cost to So one complaint that we often had with respect with our platform is that since it's a huge platform, we have to always justify the cost for it. So we were we were very sure that we didn't want to go that route, because we just saw 5x capex needs. And Elastic in general recommends you to use SSD nodes, which are fairly expensive, right? I mean, it's not cheap. So that was another thing that really was
great. Good. There's a clarification of a previous question about Clarity and Pivot. So Clarity is monitoring, which is already covered. Pivot is a web-based query interface that allows you to issue arbitrary queries with facets based on introspection of the data. Was there any equivalent to that in the new system that you used?
So yes, basically you can explore Tabix. So Tabix is the equivalent. One of the customer is actually exploring to basically issue. So like I was explaining earlier, we have like PromQL, we have the SQL support on the API and things like that. But these are essentially at the end of the day returning some data in JSON format or PromQL response format. So to answer question for interactive exploration, right? Data exploration in real time as you want to query multiple tables or join across tables. You just want to discover the schema, things like that. You can use Tabix. I haven't personally used it, but I have seen how it works. But we are actually in the process of looking into it, like how we can support it for our customers at eBay. But so, Tabix actually looks great.
So to give a better clarity here, so I think what Mohan was speaking about our the future iterations for this platform, right, wherein we want to onboard generic events use cases, and some people within eBay are already using ClickHouse in their limited capacity. So since we are like the centralized platform, we were looking at providing this at scale. So as part of that, there were questions around this, whether they can use Tabix and things around it. But what we generally prefer is to come with a standardized way, like come onto our platform and do this visualization. For the SQL support, what we do is something different. What we have done is that we ask them, okay, you can host your own workload, Grafana workload with the open source ClickHouse ClickHouse data source plugin, and just set your authentication headers properly, and then we would entertain you. But of course, we'll the policies around rate limiting and other quota-based thresholds are always applied. But yeah, that's some.
We're getting close to the top of the hour, so I'm going to try and just get 3 more questions here before we close up. Let's take the next one. How many types of clusters are there in ClickHouse as opposed to Druid, which has 5+ zookeepers? How does the performance compare to Druid?
How many clusters? I think the question was how many components, right? Probably. So it says ClickHouse backend and the zookeeper.
Yeah. Did you just have a single cluster definition with a couple of shards?
No. We have actually right now as we speak, we have like 4 or 5. I think we have 4, which is in production use.
Right. And you have a couple of 2 zookeeper ensembles, or how many?
We have zookeeper per cluster. We typically don't go with a model where we share a zookeeper across clusters. I don't know whether that's a.
That's also our recommendation. Great.
Okay.
And performance compared to Druid. I think you've talked about this, but you were pretty impressed. It sounds like.
Yeah, especially with the ingestion and stability overall on our Kubernetes platform.
Great. Here's a great question. Does ClickHouse provide ways to backfill older data?
No, like backfill, you have to do run some kind of there's a migration tool, that copy a tool that you can run to copy some of this data. But if you just create a new materialized view, I think it will just apply from that point in time, right, Robert? If you can.
Correct. Yeah, there actually is the ability to backfill. There, for example, this is. But it depends on exactly what you mean by that. So if anybody wants to go deeper on that, feel free to contact us later on. I'm going to take one final question here, which I think is a really interesting. What's the storage on each node? Because you're in Kubernetes, and I think this also is relevant to another question, which was whether you'd experience any performance problems with Kubernetes persistent volume. So can you talk a little bit about the storage you're using and how you manage that in Kubernetes?
Yeah, so we are using persistent volumes only. In terms of the size, Mohan, do you remember?
Yes, we have around 12 terabyte. This is basically for OLAP data, approximately 12 terabyte for 3 weeks worth of retention.
No.
So this
Sorry,
includes,
per node, per pod.
per node, it's around 580 GB right now. Around 600 GB, let's say. Yeah.
Okay.
And
we have 20 pods.
What kind of storage were you using underneath? Was it network attached? Or local?
It's a local.
Okay, great.
Local SSD.
Interesting. Okay, great. Yeah, that's and so that did you have any issues with? And I think this goes to this question. Did you have any issues with pod scheduling or things like that? Because you
Yes,
obviously have to schedule. If you could talk about that a little bit.
Yeah, there was a few issues with respect to so what happens sometimes is that, say, your PVC, like you lost a PVC, and your pod, the pod keeps to come up on the same PVC always. So at that point in time, you will have to get in and clear up the PVC and then spawn the pod again. There are a few issues like that. It may be very specific to how eBay runs Kubernetes within our infrastructure. So I'm not very sure whether it's like a more general problem or not.
Yeah, I thought it was interesting because we do know that managing PVCs effectively and, for example, not losing storage is definitely one of those areas where if you're operating at scale in Kubernetes, you do want to pay attention to that. In general, we haven't seen a lot of problems on our side. So, and it sounds like it wasn't a big deal for you as well.
Yeah, but it does happen like occasionally, but it's okay. At some point in time, the replication does catch up. So it's fine. Yeah, okay.
You know, we're 4 minutes over the hour. We have more questions, but I think we're going to close now. If you have additional questions, feel free to post them out to info@altinity.com. We'll get them relayed to Sudeep and Mohan. And Sudeep and Mohan, thank you so much for an absolutely awesome talk. It's just been a total pleasure hearing about this and hearing, seeing the result of all the work that you've done over the last year or two to set up this system on ClickHouse.
Thanks, Robert.
Yeah.
Thanks for.
Thank you, Robert. Thanks for providing the opportunity to talk today.
It's a pleasure. I'd like to thank all the attendees as well. It's wonderful to host you today. I hope this was useful, and we look forward to seeing you at our next webinar. Thank you very much and have a great day.
Bye.
Thank you. Bye.